In this video, we want to continue to talk about expected value and look at some examples of expected value. Now, if you remember, the way we found expected value is we took x times p of x, and then we added them all up. So we looked at some examples. The one example we looked at was this game of drawing bills out of a box and said, what was the expected value? What could you expect to happen if you played this game over and over and over again? And we got our expected value to be 7.25. That means if you played this game repeatedly, you would get $7.25 on average every time you played. We then said, well, what happens if the person you charge $5 to, and if we charge $5, it drops $5 to $2.25. But every time you played, on average, you would get $2.25. So as you look at that, the question becomes, would you play the game? Is that a good game to play? And what we want to look at today is this. If your expected value is positive, that means if you play this game over and over and over again, you're going to win. If your expected value is negative as you play this over and over and over again, then you will lose. So what we want to do is look at some more examples to kind of see how that could happen. So let's look at an example. If a player rolls 2 dice and gets the sum of 2 or 12, they win $20. If the person gets a 7, they win $5. It costs $3 to play the game. So what's our expected value? So first, we got to consider what are the possible outcomes here. Well, the first possible outcome is you lose 3. The next possible outcome is you win 5. Now we're assuming here that if you play 3 and you win 5, that you walk away with 8 at the end. So you're 5 more than you started with. We always want to consider this as how you were different than the end. If you were to do this and say, okay, you give $3 and you walk away with 20, you'd only have 117. And it doesn't really matter how you calculate that, just as long as we're all doing it the same way as we look through these. So now we need to figure out what's our probability. And rolling 2 dice and getting the sum, if you remember, we looked at this before, we had this chart. So if we want to figure out all the ways you can get a 2 or a 12, you can get a 2 up here, or you can get a 12 down here. So that's 2 ways. So winning 20, there's 2 out of the 36. To get a 7, you can get a 7 by 1 and 6, 2 and 5, 4 and 3, 3 and 4, 2 and 5, 1 and 6. So there are 6 ways to get 5. And then all the other 28 are going to lose. So we want to determine what's our expected value. What is our mean? Now, to do that, we're going to get out a calculator. And there's a couple different ways you can do this on the calculator. The one way to do it on the calculator is just to type it in directly. And if you don't have a TI-84 with you, this is the easiest way to do it. You just type each x times its probability, and that will find your expected value. The other way to do is to go into edit and type these into edit. I have a little bit different here, different order, but I think I have them in there the same. And then you go to stat, one variable stat, make sure it's L1 and L2. You hit enter, and we get the same thing. Our mu is negative 0.389. So that tells us that our expected value is negative 0.389. That means in playing this game, on average, every time you play, you are going to lose 39 cents or 39.89 cents. If you play this game over and over and over again, you will lose money. because your expected value is negative, not positive like our last example. But now let's say this is a fundraiser for you. And you're going to have 200 people play this game. So if it's a fundraiser, you want to raise money. So you're going to hope that people lose money. So if we take this number times 200, that's going to give us 77.8. So if we have this game and we're playing this game and it's going to happen 200 times, we can expect to make $77.80. Now, that means these people that are playing are going to expect to lose. Is every person going to lose? No. Some will win. Most will lose. On average, they're going to lose 39 cents every time they play. So on average, we're going to win that. But some people will end up with 20. Most will end up with -3. And as you can see, this is basically the mode of how gambling or casinos work. Your expected value is always negative. You're going to lose. In the long haul, the casino, the lottery is going to make money. Let's look at another example. Pick 3. $1 bet gets $500 back. So we have, you bet $1, we could lose $1. You get 500 back. So we'll say that's, you walk away winning $499. If you bet 1, 2, 3, that's your expected value. So the question is, if we have 3-digit number, how many 3-digit numbers are there? Well, we're going to assume for a second that we have 3 digits, and we will go from 0, 0, 0 to 9, 9, 9, and all the numbers in between. So that will be a total of 1,000 numbers. So our chance of winning with 1, 2, 3 is 1 out of 1,000. Our chance of losing is 99 out of 1,000. We get our calculator out, and I'm just going to do this one right on the screen. We take -1 times 999 divided by 1,000 plus 499 times 1 divided by 1,000. Let me get to there. Now let me show you if we, by chance, did this 500 instead of 499. It doesn't change our expected value that much. So that's why I'm not too worried about, is it 500, is it 499, whatever. They both give you about the same answer here, which is about 40 cents. Okay. So our expected value is about 40 cents. So in this example, you can see you have a positive expected value. That means if you play this game, you would expect to win 40 cents. Not very likely, but because of the value, that's what would happen. So this is just kind of a made-up example of pick 3. This would not actually really work for any sort of casino or lottery because the expected values for those are always negative. You're going to lose. Here's another example, Mega Millions. Let's say there's a $500 million jackpot. Okay, so that's how much money, 500 million is how much money you win. Ticket costs $2. And the way the Mega Million works is you pick 5 numbers from 1 to 70. Now, when you do these kind of lotteries, the order doesn't matter. It doesn't matter what order they pick them. So it's just they pick the 5 numbers. So if we're thinking about actually calculating this, it would be a combination, not a permutation. Combination order doesn't matter. There's one mega ball you have to pick from 1 to 25. And I'm just going to give it to you. The odds of picking the right number are 302 million. So there are 302 million possible numbers. Now, you'll notice if this jackpot gets big enough, you can actually have more money than there are possible combinations. However, the lotteries do not let you just go in and buy all tickets. They have rules against that. So let's find our probability distribution. So you have the possibility of losing $2, or you have the possibility of winning 500 million. Your possibility of winning is 1 divided by 302,575,350. And your possibility of losing is, I am just going to write that as 1 minus this number. That makes it much easier when I go to put it in my calculator sometimes. So now, if we go to our calculator, and I have -2 -2 times 1 minus 1 divided by 302,575,350 plus 500 million times 1 divided by, you could do this in your list, L1, L2, as I was saying before, sometimes just as quick to type it in here. We type that in, we hit enter, and we get -0.348. So we got our mu to be -0.348. So you can see in this example, our expected value is negative. We expect to lose money. Let's look at a couple other examples. Let's look at roulette. Okay, and if you have ever looked at roulette, that's where they spin the wheel. And so we're betting $5 on odd. So the way roulette works, if we bet 5, the possibility to lose that, we win 5. Now the question is, what are our probabilities? Well, to determine our probabilities, we got to know a little bit about roulette. And it kind of depends a little bit on where you're playing. Here are the 2 roulette wheels. Let me back up here. Okay. Here are the 2 roulette wheels. You will see the American roulette wheel has numbers from 1 to 36. They're black and red, odd and even. And there's 2 green, a 0 and a 00. The European or French roulette wheel has numbers 1 to 36, but has a single 0 that is green. This 0 does not count as an odd and even. I know mathematically 0 is even, but in roulette, it's not odd or even. It's not black or red. It's something different. So you can see the American roulette wheel actually puts the odds against the player. So let me show you what I mean. So if we are betting on an odd, there are, when you play roulette, there are 18 that are even, there are 18 that are odd, and there are 2 that are neither. There's also 18 that are red, 18 that are black. Now they're not all odd or even the same. And then 2 that are neither, which are the green. And if you look, you can see it's not some red, some black, or odd and even. They mix it up. So what's the probability of winning on an odd? That's going to be 18 out of 38. The probability of losing is 2 out of 38. Now let's look at a different situation. Let's say we bet $5 on just the number 7, a single number. And if you get that right, you win 175. The difference is your chance of winning is only 1 out of 38. and your chance of losing is 37 out of 38. So let's do both of these. Let's go to our calculator, and we have -5 is 20 divided by 38, plus 5 is 18 out of 38. And we get -0.2631. Let's do the other one. We have -5 is 37 divided by 38, plus 175 equals 1 divided by 38. And what you will see is our expected value is exactly the same. The odds in roulette of getting black, red, whatever it is, your expected value, let me write that down, -2.63. Your expected value is always the same. Your expected value is -0.263. Now, that should say that is a bet of $5. If you look online and you change this to a bet of $1, it's just this number divided by 5. And no matter what you bet on in roulette, the way that this game works is your expected value is always the same. So you bet on odd or even, you got a much better chance, almost 50, but not quite, a much better chance of winning 5. Where over here, you have a not very good chance, but of winning 175. And there's all kind of stuff you can bet on roulette. Here's what the board looks like. You can bet on red or black, odd or even. You can bet on like this first set of 12 numbers or the last set, or you can bet on individual rows or all different kind of stuff. The first 18, the second, there's all different kinds. Everything you bet, if you bet $5, you will get the exact same expected value. It's the way the game works out. But notice it's negative. The casino is going to make money. You're going to lose. They don't big casinos with lots of fancy lights because they pay out more money than they bring in. If you go into a casino, every single game will have a negative expected value. You're expected to lose over time. Is it possible to go in and win? Yeah. But if you keep playing, you're going to lose. Now, as we look at this, you may think, okay, this is gambling. This is playing these games. This doesn't really apply to anywhere else where I can use this. And actually, that's not true. The most important place this is used is with insurance. Insurance is basically gambling. What's going to happen in the next year? Why, when you fill out your insurance, do they ask you questions like, are you a male or a female? What color is your car? What kind of grades do you get? Because they have the data and they know if you have good grades, you are less likely to get in an accident. That doesn't mean if you have bad grades that you individually are a good or a bad driver. But on average, at looking at all of the statistics and the probabilities, if you are a girl that gets good grades, that drives a simple sedan, that has a 2-parent home, that has one older brother and one younger sister, and you live in a house, both of your parents are college educated, all that stuff goes into it, they're going to say, boom, here's the probability you get in an accident next year. And that's how they determine your insurance. So let's look at an example. Jim's a 60-year-old male, reasonably good health, wants to take out a $50,000 life insurance policy. What's the probability of death each year is given? What's the expected cost to the insurance company? So we're going to look at just the 60th year. And there's 2 possibilities from the insurance company's side. One, they could pay out nothing. The other is they could pay out $50,000. Now, is that a positive or a negative? They're going to lose $50,000. We're not putting any cost in here, right? The probability they have to pay out is that probability. The probability they don't have to pay out is this probability. So you can decide what's winning and losing. You know, getting money, insurance money is not necessarily winning because something bad has happened. But you can put those in, and we could, if we did that, we get negative about 595.5 is our expected value. That means on average, an insurance company is going to lose $600 a year for every person with that policy. Some will live, some will die, more will live, but on average, you could expect to pay out about $600. So if you're the insurance company and you want to make $300, how much should you charge Jim for this policy? Well, if you're expected to lose $600 and you want to make $300, you should roughly charge, I'm rounding here just to make it go quicker, roughly charge $900 a year. If you're expected to lose about $600 just on having to pay it out, and then you charge every person $900 roughly, that gives you roughly $300 profit. And when we think about expected value, this is a huge area. Everything, car insurance, homeowners insurance, medical insurance, all of that stuff, how much you pay is based on what's the probability and what's the expected value. How much are they expecting to pay for you this year? That is how they calculate what your premiums are. And that comes from what's the expected value for you or for any person on any year based on the information they know. And they have vast amounts of information so they can calculate the probability of a person dying, a person getting sick, a person getting in the accident, destroying a car, or whatever it may be. Use those probabilities to calculate your expected value. So it's maybe not as fun as a gambling example, but maybe more useful and more real world is dealing with insurance. All right, that is the last part of 4.1. This was actually part 3. You can now do the last homework from part 3.